This video, we're going to solve some trigonometric equations that are in a form that is factorable. Usually these are going to be in quadratic form, like 23, 24, and 26, but they could appear to be polynomials of higher degree, like number 25. And we're going to use something called U substitution to help us with these. So look for your trig function here that is first degree, and that's going to give you a hint what u should be. So in number 23, we should let u be equal to cosine of theta. And then we make the substitution that cosine squared theta is the same thing as cosine of theta squared. So u squared is cosine squared theta. So this is going to be u squared plus 2u plus 1 equals 0. We're going to factor that into u plus 1 times u plus 1, or u plus 1 quantity squared. That means that u plus 1 is equal to 0, and u is equal to -1. We make our substitution back to replace u with cosine of theta, and then we solve this equation here to say that theta is arc cosine of -1. There's only going to be answers in these problems between 0 and 2 pi, and there's only one place between 0 and 2 pi where cosine is -1, and that's at pi. For number 24, 2 sine squared theta is equal to sine theta. We want to bring the sine theta over to make this 2 sine squared theta minus sine theta is equal to 0. We want to factor out a common factor of sine theta. And I, again, can do my u substitution here, but let's just keep going here. Sine theta is 0, or 2 sine theta minus 1 is 0. So sine theta is 0, or 2 sine theta is equal to 1, and sine theta is equal to 1/2. So there are two places where sine is 0 on the first revolution, and that's at 0 and pi. There are two places where sine is 1/2, and that's at pi over 6 and 5 pi over 6. So I'm going to union these two together, say that theta is equal to 0, or pi over 6, or 5 pi over 6, or pi. Number 25, we have cosecant to the 5th theta minus 4 cosecant theta is equal to 0. I'm going to factor out a cosecant. Make this cosecant to the 4th theta minus 4 is equal to 0. I see a difference of 2 squares going on there. This is cosecant theta times cosecant squared theta minus 2 times cosecant squared theta plus 2. So this is going to be cosecant theta is equal to 0, or cosecant squared theta is equal to 2, or cosecant squared theta plus 2 is equal to 0. Sorry, minus 2 equals 0, set each factor equal to 0. Don't get ahead of myself. Cosecant can never be 0 because cosecant has to be greater than 1 or less than -1. Cosecant squared can never be a negative number because we can't square a number and get a negative in the real world. So I'm only left with this part here to give me my solutions. That cosecant squared theta is equal to 2, which makes cosecant of theta equal to plus or minus root 2. I know where that's at, but let's go ahead and change this to sine to make it easier for you. 1 over root 2 So those are all of the reference angles of pi over 4 on the first revolution. So that's going to be at pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. We have one more in this series here. And that's going to be that sine squared theta plus sine theta is equal to 0. I'm going to take sine theta out and make this sine theta plus 1. Sine theta equals 0, or sine theta plus 1 equals 0. Be sine theta equals a -1. So where is sine 0? That's at 0 and pi. Where is sine -1? That's at 3 pi over 2. So union those two sets together, and we have our answer. We'll come back next time and we will talk about using our calculator to solve some of these by finding zeros on our calculator or finding points of intersection. We can do it either way, but some of these that are coming up, we can't solve them by hand with the identities that we have. So we'll do that next time.